So till now we have discussed about the various kinds of relays that are used in protection of various types of equipment. Okay. Now this relay is going to give basically a signal to the circuit breaker. So we have to discuss a bit about the circuit breaker. Now at a basic level, the circuit breaker is going to have two contacts which is connected to the power system. One is going to be, usually it will be a fixed contact, while the other will be a moving contact. Now they will be touching each other. Different circuit breakers will have different structures. Okay. So what happens when a relay is going to give a trip command to the circuit breaker? This moving contact, it is going to move in such a way that the connection is now lost. There is a connection initially and that connection will be lost. Okay. But what happens when the connection is lost? Let us consider it like a switch. Okay. Say this is the moving contact. Initially it was closed, let us say. Now it is being moved away. Okay. Now what is going to happen? There is going to be an arc formation so that there is still an electrical connection between the two contacts. Okay. So the circuit breaker should be able to extinguish this arc. What is meant by an arc first of all? So under normal working condition, there is a huge amount of current that is flowing through these contacts. Now when the circuit breaker is trying to break away the contact, a high voltage gradient is observed. Then what is going to happen? The material that is surrounding these contacts, that material is going to get ionized because of this high voltage gradient. That is called as field emission. So a high voltage gradient will lead to field emission. So the ionized particles that are produced due to field emission, these will sustain an electrical contact between the two contacts, which is what we call as the arc. Now once the arc is formed, what is going to happen? There is going to be a very high temperature that is produced. Okay. So arc formation results in a high temperature. Now this high temperature in turn, what is going to do? It is going to further ionize the particles by means of thermal ionization. Okay. So thermal ionization will occur. This thermal ionization will now sustain the arc. Okay. So the arc has been formed by field emission and it has been sustained by thermal ionization. Okay. Arc is sustained or maintained, you can say. So now when the circuit breaker is given the trip command, another challenge here is to extinguish the arc, right? So that is done by the insulating medium in which the contacts of the circuit breaker are kept. Okay. So primarily the insulating medium present in circuit breaker is going to have two major functions. What is that? First one is, anyways, it should serve as insulation between the contacts, fixed and moving contacts, right? So between the CB contacts. CB means circuit breaker. So we'll use this abbreviation often. Okay. What is the second function? It should be able to extinguish the arc that is formed. So depending on the insulating medium that we are using, we have different kinds of circuit breakers. So what are the most commonly used insulating materials? So commonly used insulating materials are, one is air. Okay, simply air. Next we can use certain kinds of oil. Next is SF6 gas, sulfur hexafluoride. Okay, and also vacuum is also used. So depending on the voltage level and depending on the application, we can use different types of circuit breakers. Now in order to extinguish the arc or interrupt the arc, there are two major methods. One is the high resistance method. These are arc interruption methods. So first is the high resistance method. and the other is the low resistance or zero current interruption method. So in the first method, as the name goes, the high resistance is made very high, the current is forced to become 0. So what are the various methods that are used here? First one is lengthening of the arc. So we know that resistance is directly proportional to length. So if we lengthen the arc, then resistance is going to increase and it is going to get extinguished. Okay. And next is splitting of the arc, meaning that the area of cross section, it is reduced, right? R is inversely proportional to area of cross section and it is proportional to the length. So we are making use of this principle here. Okay. Another method is cooling. Now once the temperature is reduced, whatever ionized particles were formed initially, they will naturally combine back with their molecules. Okay. So deionization will occur. So this high resistance method, this is usually only confined to the low voltage and medium voltage circuit breakers. Okay. The next one, which is the low resistance or the zero current interruption, this is possible only for AC systems. What happens in AC systems? There is going to be alternating current, right? So when the current reaches a natural zero, then the arc is extinguished naturally. So this can be explained by two theories. Okay, the very first one is called as the energy balance theory, and the second one is voltage race or Slapian's theory. Now according to the energy balance theory, if rate of heat that is being generated, heat generation, is made lower than the rate at which heat is being dissipated between the contacts, then the arc can be extinguished. Okay, so this is one way of extinguishing the arc. Now what is the voltage race theory state? So according to this, if the rate of removal of ionized particles, there are ionized particles because of which the arc is occurring in the first place, right? Now these ionized particles, they are removed at a rate which is faster than the rate at which the particles, ionized particles are produced. There will be a speed at which ionized particles will be produced. Okay, so if you can remove the ionized particles at a faster rate, then also the arc can be extinguished. Okay, so if the rate of removal of ionized particles is made faster than rate of ionization, then arc can be extinguished. Here we have an example of an oil circuit breaker. This is an oil circuit breaker, and here we have an air circuit breaker. So here you can see there is a fixed contact here and the moving contact is here, and both of these contacts, they are present in the oil. Now whenever the relay gives trip command, you can see that this moving contact, it has a piston like this, right? Now when the trip command is received, this moving contact will move away from the fixed contact, and when it is moving away, then an arc is formed in between these two contacts. So that will be extinguished in the oil medium, and when the arc is formed and it has to be extinguished, the oil will expand because of the arc formation. For that we need an air cushion. Okay, so this is the rough working of an actual oil circuit breaker. And next you can see there is a air circuit breaker here. Here where is the fixed contact? This is the fixed contact and this is the moving contact, and arc will be formed in between these two contacts when a trip command is given. Now even in air circuit breakers there are going to be different mechanisms. Okay, so this one is an air blast circuit breaker. When the trip command is given, air from this air reservoir, it is going to be blasted into this arcing chamber. Okay, that will help extinguish the arc.